Hello, statistics class. I am going to go over or look at the notes for chapter 4, section 4 from the beginning. So some of this stuff I have done in class, but it has been a while with everything going on, and I feel like this will make more sense from the beginning going through these notes rather than just picking up in the middle of a section. All right, so I'm starting at the top. So here we go. Unions, intersections, and complements. The union of an event of events A and B is the part, or it is the union of two events is the event that either A or B will occur. That means whatever the probability of A is and whatever the probability of B is, A union B is that one of those occurs. And we symbolize that with, if you can see my cursor here, with this upside down U looking thing. It's not actually a U. It doesn't have the tail like U's do in the letter the letter U. But it's an upside down U looking, or sorry, it's a normal looking U thing. The intersection's upside down. It's a normal U looking thing. You can see it down here also, a little bit wider depending on the font and the textbook. The not the opposite, but another thing with that, with a union, is either A or B occurs, or both, but either A or B occurs as the union. So all of A and all of B together is the union. The intersection, on the other hand, is the probability or the event that A and B both occur. So that would be the overlap. So if I wanted, now that I have union intersection defined, let me just see if I can come up with an example here. If I have probability of A is rolling a six-sided die, and it's rolling A is even, all even numbers. And let's say B is 1, 2, and 3, rolling 1, 2, and 3. Well, the union of A and B would be either rolling an even number or 1, 2, and 3. So if you roll the die and you get 2, that would be both A and B. That's part of the union. But even if you got 1, that's part of the union also. Even though it's not part of A, it's part of B. I don't know. Hopefully that makes sense. The intersection, on the other hand, is the probability that both events occur. So in that case, the only thing, the example I used, that was rolling a die and having the even be A, an even number be A, and 1, 2, and 3 be B. So the union would be the number 2 would be the only value in that example that would be an intersection, the event intersection, because that would be the only number that meets both A and B. Hopefully that's making sense. The complement, another definition is the complement. The complement is denoted with this superscripted C. So the complement of A in this case, which was all even numbers, would be all the odd numbers. Anything that's not in A, but still in the total sample space. So visually, the union looks like this. This is a Venn diagram, and the union would be everything in A. This is all the evens. This is 1, 2, and 3, and 2 would be in the middle. Over here would be 1 and 3, and over here would be 4 and 6. And if any of that occurs, it's in the union. The intersection would just be 2 in our example that I was saying verbally. And the complement going on here is everything that's not in A, but still in the sample space. So the die has 1, 2, 3, 4, 5, 6. A is evens, 2, 4, and 6. So out here in the sample space, but not in A, would be 1, 3, and 5. Okay, let's look at an example. 2 fair coins are tossed. The outcome is recorded. These events, the events of interest are observing at least one head and at least one tail. we're going to define A be the intersection of AB and the union of AB, and the complement also. Oh, did I mention the intersection symbol? I think I might have glossed over this. Is an upside down U. So the U and then the intersection is denoted by an upside down U. That means intersection. Sorry, I think I skipped over that. So example 17. So our simple events, the sample space, everything that can happen when we toss two coins, is we can get a heads on the first coin and a tails on the second coin. It gives us 4 combinations: head, heads, head, tail, tail, head, tail, tail. So event A, at least one head. Oh, first of all, I'm going to do the probability of each of these. Now, the probability of each of these will be 1/4 because it is 4 events total, and all of them are equally likely. So we take the total number of events and we do 1 over that to find the probability of each event. Okay. So event A would be at least one head, would consist of every event that has a head in it. So head head would have at least one head. Head tails and tails head all have 1 heads in the event. So it looks like the event A would look like this: E1, E2, E3. I labeled these E1, 2, 3, and 4. It didn't give us a name, so by default we label E1, 2, 3, and 4. If you have something better to use, or they tell us to do something, you can use something else, but that stands for event 1, event 2, 3, and 4. So A includes event 1, 2, and 3. B, at least one tail, would include event 2, 3, and 4. But before we do that, actually, let's find the probability of A. And the probability of A is the probability of E1 plus the probability of E2 plus the probability of E3. So there's going to be a 3 and 4 chance of getting at least one head. That's a 75% or 0.75%. Okay. So B is event 2, 3, and 4 because we're looking at least one tail. So tails, tail, and then 2 tails is at least 1 tails. Not exactly 1 tails, at least 1 tails. So we're going to look at the probability of each of these events. The probability of event 2, 3, and 4, they're each 1/4, and so it's also a 3/4 chance we see at least 1 tails. Okay. What about the union of A and B? The union of A and B will be the what these two events share. The simple events these two events share. So you can see that 2 and 3 overlap. So the union would be anything that's overlapping, and that would be, I'm sorry, this is the intersection. This is intersection. The intersection will be anything that overlaps, and you can see here that 2 and 3 are in common, so we are looking for the probability of the intersection, and that's the probability of E2 and E3. So there'd be a 1/2 chance that you'll get an event that meets both of those conditions, A and B, that you see at least one head and at least one tail. And obviously, if you get a head and tail, you're meeting both those conditions, and there's a 50% chance of that. The union would be all events because it's everything in A and everything in B, and anything they share also. But we're only doing everything they share once. You don't want to put E2 twice. So we don't want to put E2 twice or E3 twice because that's still only one event. So it's actually going to be 100%. We're going to have 1/4 4 times, and it'll be 100%. Okay. The complement of A. So the complement of A, if A is 1, 2, and 3, and the entire sample space is E1, 2, 3, and 4, then the complement will be E4. The only thing that's not in A. And that'll be a 1/4 chance of that, or 25%. And that wraps up the first section of chapter 4, section 4. And here is some book work from that section. So, all right, actually, I'm gonna stop. I'm gonna go over the rest of the notes, but I'm gonna actually stop this here and then make it a new video for the second part, the second notes. Yeah, okay. Thank you and good day.